Shrewd Manager Christianity's Position. Scientific tests propose a 1st century date of the Shroud. Part 2. In 1988, the Shroud was radiocarbon dated as medieval, 1,300 years too late to have wrapped Jesus. Videos 3.6 and 3.7 offer reasons why this C14 analysis was too flawed to be reliable. The first alternative dating study to generate wide discussion comes from chemist Raymond Rogers. To understand his thesis, you must understand linen, nodes, lignin, and vanillin. The shroud is a cloth made of linen, which comes from flax plants. Think of linen fibers as microscopic lengths of bamboo. Nodes are the solid knuckles representing points where new growth can emerge. Lignin is a structural polymer found in all plants, including flax. Vanillin disappears with time, so Rogers wonders whether a vanillin clock could be calibrated to determine the shroud's age. Vanillin was detected, Rogers tells us, on the C14 tested area, on samples adjacent to the C14 area, called Rhea's Corner, and on the so-called Holland cloth, a large linen backing cloth sewn to the shroud to stabilize it after a 1532 fire. Conversely, he reports vanillin cannot be detected in the lignin on the rest of the shroud, on Dead Sea Scrolls linen wrappings, and other very old linens. This indicates that the shroud is quite old. The kinetics of vanillin loss suggests that the shroud is between 1,300 and 3,000 years old. Even allowing for errors in the measurements and assumptions about storage conditions, the cloth is unlikely to be a medieval artifact. If he's right, this suggests the C14 area is much newer than the main body of the cloth. The radiocarbon tests essentially tested a separate cloth, so cannot give us the shroud's age, and the rest of the cloth fits a date range that includes Jesus' time. There's a lot to commend Rogers' theory. First, his sample's provenance. He had access to 32 samples from all over the shroud. This paper traces his Rhea's and C14 samples back to Luigi Gonella, scientific advisor to Turin's archbishop, custodian of the shroud. Second, there's evidence the shroud's vanillin loss was caused by age, not heat. The shroud was seriously damaged in the 1532 fire by heat on the order of 950 degrees Celsius. We see the scorches and patches. Blood degraded near the scorches, but not mere inches away. These areas got very hot, and these areas stayed much cooler. If heat caused the loss, it makes sense no vanillin would be in the heated areas. But the cooler places away from the scorches are puzzling. If the corner shows vanillin because it stayed cool, shouldn't there be vanillin in some of the other cool areas? Third, his calibration methodology. No one knows the shroud's storage conditions throughout the centuries. So Rogers modeled storage temperatures of 25, 23, and 20 degrees Celsius, and calculated a margin of error so large that of the past 3,000 years, only the most recent 25% is outside it. For his calculations, Rogers uses the same general methods he used professionally to estimate storage temperatures and ages of explosives, where he notes he could not afford to be wrong. Fourth, Rogers' observations that there's vanillin in the corner but not on the main is one of 10 reasons he gives why the C14 corner differs from the shroud's main part. Fifth, his tests are repeatable, and some materials are still available to test and verify his work. These 3 researchers are not sold on Rogers' theory. This post offers an alternative explanation, assuming Rogers' observations are accurate about where vanillin is and where it isn't. Longtime Shroud researcher Mark Antonacci, however, says we shouldn't simply accept Rogers' observations as true. There are too many unanswered questions, such as how many samples were tested, what were their locations, who did the testing, where are their studies reported, how did Rogers identify lignin on growth nodes, which nodes had no lignin. Author Hugh Ferry asks similar questions. Who tested the Dead Sea Scrolls? Who tested the Holland cloth? He also references work by researchers Heller and Adler. They tested 20 areas of the shroud and 2 of the Holland cloth for lignin and found none. They didn't have access to Rhea's samples, so they didn't test those. This challenge matters because Roger's method was to test for vanillin wherever he found lignin. How did he test for vanillin on the body of the cloth if there was no lignin? Maybe there are good answers to all these questions. We just don't know. Rogers passed away shortly after publishing. Ferry himself thinks it is likely that there was and still is lignin throughout the shroud, but that the test Heller and Adler used, the same as Rogers, is unreliable for individual fibers. In sum, what should we make of all of this? Well, we observe that none of the objections rule out a first-century shroud. We could concede them all and still conclude the shroud wrapped Jesus. Our position is that until these challenges are addressed, Rogers' findings are inconclusive, and his proposed method remains unconfirmed. Rogers himself says more work is needed. He recommends starting with known, fresh, modern flax made according to ancient techniques, including bleaching. We agree. Because the storage conditions throughout the centuries are unknown, he proposes that a more accurate age determination will require new radiocarbon analyses with several fully characterized and carefully prepared samples. We agree here too. Until the shroud's owners permit another radiocarbon test, however, scientists have little choice but to continue exploring these novel alternatives. Next, we conclude our review of recent age dating studies of the shroud.